We are running a little bit ahead, about 10 minutes ahead. So Jay, that just gives you more time and more time for Q&A as well. So next I would like to introduce Jason Greenbaum to present the IEDB Tools 3.0 Future of Tools, where Jay's going to give you all a behind the scenes look at some work that we've been doing to really improve the user experience when you're using the tools. So take it away, Jay.
Sure. All right. Can you see my web browser?
Yes.
Excellent. All right. So thanks for hanging in there, everybody. I'm happy to be able to share with you some of this work. So we've been spending a lot of time kind of rethinking the tools website, and I'm going to go through some of that, some of what we come up with to this point. And so I'm going to go through, just to kind of set it up, I'm going to go through the motivations and the vision, and tell you a little bit about what is the life cycle of a MHC1 prediction request in the new system, what we're envisioning there. Then we get to the fun part where we do the live demo of our prototype, and I'll come back into the presentation to talk a little bit about pipelines and integrating tools, and then finish up with a slide on a few additional plans and the timeline for things. So with that, so why are we working on a redesign? So you've seen all the presentations about the tools. We're really happy with the functionality of our tools, and we're really proud of all the tools that we have. But there are definitely areas for improvement. So especially in terms of navigation through the site, being able to link between tools. There are many inconsistencies among tools in terms of control elements and things like HLA allele nomenclature, and the layout and the aesthetics are a little bit outdated. And so, so we think we can do better. And so we're really thinking of completely rethinking the entire user experience. And we want users, when they come to the website, to immediately know where to go, have an understanding of what to do, and at the same time be able to provide all of the necessary tools for power users to be able to do more complex workflows. And we want to emphasize things like navigation, because we know that's currently an issue. Simplicity, making it easy to choose which tool to use for your purposes. Consistency throughout the tools, being able to integrate the tools, so take the the output of one tool and use it as the input for another. And also speed. So we want to be able to accommodate a reasonable size, a real world data set in a reasonable amount of time. And that's an intentionally vague statement, but we want it to be snappy. So, and we want to do all of this by drawing upon familiar paradigms. So things that we know work, things like things that are simple, things like REST APIs, using JSON for a data exchange format, and not directly using Jupyter, but kind of drawing inspiration from Jupyter notebooks. Right, and so to set things up, I kind of want to explain the way we're envisioning the life cycle of a prediction request. And here I'm focusing on MHC1 prediction requests, so things related to binding and processing and immunogenicity. So we're bundling all of that under this MHC1 endpoint. So on the left-hand side, I have kind of a representation of a user, or this could be an API user or somebody using the website. And so actually one of the key things is that we're separating out the back end from the front end, and we're having all of these back end endpoints that not only we're sending to our API users, but our front end will be accessing those as well. So we're kind of eating our own dog food, if you will. And so, right, so the user sends a request to the MHC1 endpoint. And that's their initial request that includes the sequences that they want to predict for, the predictors that they want to run, any other parameters. What they get in response is not the result. So what they get in response is instead a request ID. And the reason for that is we want to be able to provide a response immediately. And many of the predictions that we do are not immediate. A lot of them are computationally intensive. They'll take a bit of time. Oftentimes, with a large request, they could even time out, and you'll never get a response. So by providing a request ID immediately, we could run some maybe real quick validations, but give you immediate feedback. So then the user would take that request ID and post that to a second endpoint called get results. And what that will do is that will give you results if they're ready. If not, it will give you the status of the request. So it'll say, queued in the system or error processing, but eventually you would get your results through there. And then just diving a little bit deeper into what those requests will look like. So this is a post for a MHC1 request, so to our MHC1 endpoint, where up top we have bits of information like the sequences that you want to predict for, the alleles and lengths. And then, as I mentioned, you'd be able to select multiple different predictors. So not just binding, but also doing processing and immunogenicity, and doing them all in the same request. And so if it's a successful request, you would get something like this in response, where you get your request ID, and then the URI where you'll eventually get your results, and a bunch of other information that I won't really get into at this point. But you may also run into a validation error and get something instead like this in return. You'll get your request ID, and then hopefully a list of meaningful errors for quick validations that we can run, like your sequence contains an X at certain position and we can't handle that, or the allele name that you provided is invalid. So after you get your, you post your request and you get your results ID and URI, you can then post, hit that URI with a get request, and what you would get in response if the request was queued would look something like this, where it returns the URI one more time, and it's a status queued. There's no warnings or errors or results just yet. Things go wrong sometimes, especially with large predictions. So you may get something back like this that says, there was an error processing a request, we wish they didn't go wrong, but at least this will give you some immediate feedback, and you'll have a pointer to a URI that you could send to the help desk, and we can go investigate that further. But hopefully you'll get something more like this, where this shows a completed request. So again, the same fields up top with the URI, and now it says status completed. Then we have our results returned in a JSON format. We're not married to this exact format just yet, but it will be something like this. And we will be providing options also for different return formats as well. All right, so now we get, now we get to the fun part. And so the first thing I want to show is kind of a demo of the API endpoints through our Swagger documentation. So we're using OpenAPI or Swagger to kind of document our API endpoints. And it's really nice because it outputs this kind of living documentation and documentation that you can interact with. So you get a list of all the available endpoints. You can expand any one of them and kind of see what's available. I'm just going to go down to the MHC1 endpoint to show you how that works. So when you go there, it shows you, this is going to be a post. It gives you a little bit of information in terms of what parameters it takes. And then you can say, try it out. So we'll enter in a sequence. I'm just typing on my home keys. And an allele. There, and a method. And now when we click execute, it's actually, it's going to take that request and actually post it to the server. So it will show you, it'll show you actually what it did in curl. So you could actually take this and do this on the command line, and the URI that it hit for this request. And now this is the response from the server. And this happens in real time. And I think this is a really nice way of capturing this stuff in documentation. It's documentation that you can play around with. So we got our results URI. So we have a couple of ways of going there and actually fetching the results. One, we can just take this whole thing and paste it into our browser. Oops. That's a different project. Copy didn't work. Copy, paste. Okay, and so obviously, it was a small prediction. The results are ready, and you can see we have the output in JSON format here for those peptides that we predicted. You can do the same thing right through this documentation here. You can just take that request ID and find the results endpoint, try it out, paste it in there, hit execute, and again, it shows you what it does through curl, and we see the response back from the server here. So we get a 200 response, which is what we're hoping for, and then a nicely formatted JSON output. So that's the backend, and that's what we're providing for API users, and that's also what is going to be driving the front end. So here's our current prototype of what we're calling our T-cell class 1 page, and this is we spent a lot of time on thinking about all the elements on this page and trying to make it as simple as possible for users, where users will know what to do. And so you can see it's a cleaner design than we currently have. Up top, we have this giant text box where it should be obvious that's where you are going to put your sequence. You can just type a sequence in there. You can also drag a sequence from the desktop. Hold on, I can demo that. I don't know if you could see my desktop, but I'm just dragging a file in there. And I dropped it, and it now populated that box and gives you a little initial validation, counting up the sequences that are in there. Then we have this length slider where you can select the lengths that you want to predict for. By default, it's set to 8 to 11 mers. And then the alleles, which will apply to all of the predictions that are done on this request. The plan is to make this more similar to what we currently have on the main IEDB website, which I don't know if everybody's familiar with, but there are some nice finders there that allow you to kind of navigate the hierarchy through the MHC ontology. And then there will be autocomplete as well. We just don't have that implemented just yet. So I have my allele. And then now the cool part down below is where we can, we have MHC binding selected at this point. And, just like we currently do. You could select the different methods that you want to predict for. And there's another drop down here where it says add another prediction. So I'm going to go and do that. So we could add another binding prediction. So at the same time, when we submit, we will not just get the SMM results, but we'll also get the NMHC Pen EL results. But then, as we were saying, that's not just binding, but also we can do our processing prediction, we can do our immunogenicity prediction, and do everything in parallel, so that when we click run and we get our output, the outputs from these additional predictions will appear as columns to the right of our initial output. This is a prototype. We don't have it all working now, but we do have this working. So I can show you what this would look like. So I'm just clicking run on doing a simple prediction, and it should be a lot faster than this. It normally is, but that's what I get for doing a live demo. I'm going to wait a few more seconds, and if not, I have a couple of backup screenshots I can share with you. But what will happen is we'll get a table of results at the bottom. It'll look similar in terms of content to what we currently have as an output for the MHC1 tool, with a little bit more functionality. And yeah, one more second, come on. There we go. Okay, shouldn't take that long, but anyway. So we have our output now. And like I said, I mean, this looks similar to the current output for the class 1 tool, where we have, one row per peptide and allele that we did a prediction for. If we had additional, if we had done additional predictions, like I said, we would just add more rows to the right, applying them to that same peptide and allele. So right now, I mean, we can just do some basic sorting where we'll be adding some smart filtering here. You can see these buttons up here where we say display columns. So we'll be able to customize the view, select the different columns that you want to show or hide. We will have links to be able to share this output with others, to share the data, download this in different formats, and then also pipe this output to other tools. And so that will bring me back into the slide deck to talk real quick about pipelines. And so that the whole idea of a pipeline is to be able to take the output of one tool and feed it as input to another tool and kind of chain these things together, maybe even rearrange the way you do things. And I'm just showing an example here of a potential pipeline. So say you start with a FASTA file of proteins. You want to run that through the MHC1 binding tool. You're going to get your peptide MHC binding predictions as output. Do a little bit of filtering on there, send it to the clustering tool. You end up with some peptide clusters. And then you want to display those in the immunome browser and look for these binding hotspots on proteins. That's something that's totally doable right now on our current website, but it would be, you would have to do it in 3 or 4 different steps. There'd be a lot of manual intervention. And it's something that we want to be able to enable users to do without leaving the website, just to kind of build these pipelines and use the website to execute them. So in terms of plans for things that I didn't cover. You might have noticed some of the API output looks a little like it might be a little bit difficult to handle on your own. So we are planning on also providing access packages to the API. So we'll be providing Python and R packages. So you won't really even have to think too much about implementing that stuff on your end. The output formats, like I said, we will be able to customize those. The pipelines, we want to be able to provide stable links to pipelines. So a user builds a pipeline, they could share that pipeline with others with or without the data. So maybe just the steps of the pipeline. We'll be thinking hard about what pipelines people would actually want to run and maintain a list of curated pipelines. And then we'll be doing this all by on top of a backend where we're using a HPC, a high performance cluster that gives us the ability to monitor resources and allocate resources fairly, and gives us a nice queuing system. And some of the key dates. So next month we have a review by an expert committee, and we'll be getting feedback there. We hope that we plan to have the alpha site available early next year, and that will be just the T-cell tool that I was demoing, and then the remaining tools will follow. We'll take it from there, and that's all that I have for this one.
Excellent. Thank you so much, Jay. Thank you for that. And I hope everyone watching really enjoyed that. There's a lot of exciting things happening in the tools space, as in every other space, but particularly here. So yeah, it's something to look forward to in the next few months for sure. And now, while Jay has a look at some of the questions that have been submitted, I would like to invite Bjoern back, and we'll answer some of those questions. And Bjoern, I think I might give it to you to answer one of the first ones.
Yeah. Okay, and I apologize for, I ran out of steam definitely in presenting 3 in a row. So I hope you can forgive me for that. The first question I see here, and actually, I mean, we kind of anticipated that there wouldn't be much questions for Jay because of the future of tools is obviously not questionable. But I'm hoping he can help me still by answering some of these. I'll start on the top. And the first question is there any difference in all algorithms? If yes, which is best one? So this is, I'm presuming, is about the B-cell epitope prediction algorithms that I presented. And out of the ones that were presented, definitely if you have no access to a crystal structure, no access to 3D data, BepiPred 2.0 is the one that we would recommend. If you do have access to crystal structures, 3D, I keep on saying that, 3D data, then Discotope 2.0 would be the one that we would recommend. Jay, can you take one, or?
Yes, I just saw one about Discotope. So will Discotope identify epitopes that span 2 different chains of a protein? No, it will not. It looks at the chains independently.
Then can we get the cross-reactive epitopes using the IEDB interface? Okay, sorry, I just read that and I can't answer that. As in, I am not sure what that means. So the
Bjoern?
Yes.
I was typing an answer to it.
Okay, good. Then you want to answer it live?
It was answered in the slides from day one. There were 2 examples. And so I was putting in the answer where they could find those examples.
Okay, good. So let me go for the next one. Will tools like GLIPS clustering or MoDEC be integrated in the tool set? Please send us a link to references that describe these. I'm not familiar with the names immediately. We always like to integrate more tools. again, like we are specifically for tool parts that we are not covering well. We love to host other people's tools, but obviously we have to get permission to do that, and we can't do that just by ourselves. Jay?
Yeah, so I actually see one for the redesign. So it says, Jason, will the future website standardize the output of the multiple tools? For some, lower score is better, and for others is the opposite. I like to think that we actually already have the output standardized, which is and I'm thinking specifically of the binding tools where we do the percentile ranks. So the percentile ranks is our attempt to standardize the output. The underlying tools, they may output scores in on different scales and that go in different directions, but the attempt at normalization is the percentile ranks, and maybe we will try to make that clearer on the redesign, because that definitely seems to be a point that trips people up often.
Actually, and along the same lines, there's the question, could you please extend on scores for residues in BepiPrep, positive and negative? So BepiPrep is one of those where a high score is good. And I agree with what Jason was just saying. So I think we should be having probably everywhere a percentile rank score as an output, and there it should always be clear that the top percentiles, so meaning 1% or something like that, are going to be the highest likelihood candidates. And I mean, yes, we are to blame to this for some extent, but not really, as in just for binding affinities, KD values, IC50 values, the lower the better, half-lives, the higher the better. This is just how biology is. So the prediction outputs often reflect these kind of underlying molecular measures that are being modeled. And then there is no universal like low better, high better role for those either.
So yeah, I don't see any other questions I feel comfortable answering.
Okay, so I can take another one. So is there any cancer-related or cancer neoantigen epitopes at IEDB? How can we find them? So this is again like something that was actually on the first day. That's not a tool questions, that's a database question. And yes, they are there. The easiest way to find them is to look for on the IEDB. There's like a disease category, which is it has cancers somewhat hidden. And that's probably the easiest way of finding all of them that you're interested in. And we are hoping with the revision of the database and the supplemental funding that we've gotten to be able to have some more intuitively accessible data. And if you have a specific question, please follow up by email to the help desk or so, and then we can follow up with that as well. Given that there was no new questions, I'm presuming I should try my hand at the last one, which is for bioproduct immunogenicity prediction. What would you suggest to implement? Binding predictions, immunogenicity predictions, or structure-based predictions, Scepter? So here, bioproducts, I'm assuming that it's going to be like biologicals that are going to be injected into humans, where the typical concern is that you're going to get like an immune reaction to it. Typically, what we have found, what people have been asking us to do is typically MHC class 2 binding predictions. Typically, that is considered to be to having a class 2 restricted epitope as part of the biologics is associated with having more antibody production against it. So that is often what we're going for, and that was also what Alex demonstrated on the first day, how the tool is trying to avoid having high affinity binders that are recognized in many people as part of your sequence, and then avoiding those specific residues. And I think for me, that's it.
Excellent. Excellent. I think I can start to wrap up.